Okay, hello everyone. Welcome back to the third video here where we're going to have our kind of hands-on tutorial creating maps in R. So there's essentially three ways that we can find shape files and census data and analyze them in R. So there's a historical, kind of outdated way now, or old school way, which is essentially you go to external websites maintained by the census, you manually download shape files into your computer file, you manually download census data into your computer file, and then you have to get into R and essentially point R to the correct file path to load in the shapefile or the maps and also the census demographic data. You have to point it to the right files, you have to load it in, and then you have to merge them together. So if anyone's worked with ArcMap or ArcGIS or QGIS or any of those other spatial stats programs, you'll know that this method is an extremely excruciating, painful method of doing things. Luckily, with new advances, we have a lot better methods that don't require us to manually download and point R to the correct path file using census APIs. And there's two approaches that we're basically going to look at. In this video, we'll look at the second approach. And then in the next video, we'll look at the easiest way to combine the maps and census data analysis, looking at the tidy census package. But for now, let's give a brief overview of what life used to look like, how crappy it used to be. And then also we'll look at our first hands-on tutorial using the API with the Tigris package for spatial data, downloading the maps, and then for the get census to get the demographic census data. Okay, so let's move on. So for the old school mapping approach, you would use like the ArcMap or ArcGIS. You'd have a bunch of spreadsheets. You'd have to add this demographic data as a layer or as an attribute onto whatever shape file you have, and you can create different like pie charts or choropleth maps, basically linking this kind of demographic data to shape files and spatial data in your spatial packet analysis software. Again, as I mentioned, you have to download usually Excel spreadsheets. You have to go to Tiger, the Census Tiger, download shape files, all from external websites. You got to find the websites, you got to find the files to download. Then you have to import all this information with ArcGIS or QGIS or R, and then basically export the merged data set into some other kind of software package to tweak the style and the aesthetics of the map. So this is extremely time consuming and something I had to do 10 years ago or 11 years ago in school, and it still gives me nightmares. And basically, this is an example. You go to the censusreporter.org. You got to look for a bunch of variables you're interested in. You download the data as a spreadsheet. If you go to the Census.gov and find the Tiger shape files, they have a bunch of their shape files on this external website. You have to download those guys into your computer. Then you have to find whatever folders you had that you downloaded them in your downloads, move them to a better folder. You have your shape extension, your DBF, and a couple other files that all get downloaded in a zipped folder. And again, you have to point your R console to finding all these folders on your desktop and then merging them together and analyzing them. So it's extremely time consuming. We have new approaches that we're going to get into more detail, specifically looking at the Tigris package to download our shape files. And then we'll look at the census variable to download the economic data. So essentially, there's a few functions that we need that we use and a couple of calls within those functions, essentially to tell R what our geographical unit of analysis is going to be. And we'll play around with some of that a little bit later. But the other package then will be the CensusAPI package, which will help us to download the demographic census data, which is your information on like the income, median income of a county, or the housing price, or whatever demographic data you want to use. So the first thing we need to do in R is we need to download and load the Census API library. And we also need to sign up for a special census key that will allow us to actually download the data from the API, okay? And if we click on this window, it's going to, you're going to type in Arizona State, you're going to type in your email address, it'll be your own email address, you're going to agree, and you're going to submit key request, and the Census Bureau will send you a unique census key that you'll be able to use, and that will allow you to access the data. So the way you're going to do this, you're going to get your census key, you're going to replace it here, and then you're going to copy and paste this into your R, start a new R script, into your R package. So I have one already that I got emailed. So basically you're going to put this here, and you're going to set the census key for your general environment. So anytime you work with census data going forward, you'll have no problem downloading the data. Okay, so again, you're going to download the Census API data first, which you should all know how to do. You can go to packages and install, and it'll come up. So you want to install that, and then you could do something like this, and then you'll have your Census API. So this is gonna allow you to download data from the census. And there's different ways to look up all the variables that are included in the census. There's a number of thousands of data sets and tens of thousands of variables. You can follow these code. I'm not going to go through it here. The next video will go step-by-step tutorial, since we're going to be using the Tigris Census package a little bit more, but just so you can get a sense of how the Census API package works, there's some way you can look through the variables. Okay, so downloading census data, there's a few arguments that you'll need to pass. You'll need the name of the data set. If you want the 5-year estimates from the American Community Survey, you're going to have something like ACS5, or you have other kinds of data set names. The vintage is a weird way to say the year, but vintage refers to the year that you want to look at. VARs will refer to the name of the variable you want to access, or the variable you want to download. And then the region will be the geography. So county, state, or census tract are all options. So you'll want to look at filling in some of these functions for the name, the type, and the vintage. And we can just, using the list census metadata, this will give us an example of all the variables that are included in the ACS and ACS5 for the year 2016. You don't need to run this command because it takes a long time to get all the metadata, but this is essentially how you would point R to the Census API to get all the list of variables in the ACS and the 5-year estimates. Okay, and you'd get something like this if you did run the code, and you could type in the finder here something like median household income, and it would return a bunch of metadata on the types of variables that are available. And the first column would be the actual name of the variable. So B19013_001E refers to the estimate for the median household income in the past 12 months. So for the year 2000, what year did we say? For the year 2016, okay? So this is a way of, all within R, we can search the database for different types of variables and information included in the census, ACS, American Community Survey. And again, we'll have the reference, the variable name will be this kind of weird thing, B19013. You got all kinds of variable names. This is going to be the actual variable name that you call into the function in order to actually download the data. So unfortunately, you can't just say, I want median household income, and then R will download the data for you. You have to get the actual ID of the variable name, and that's how you're going to get data into census data into R. Okay. Okay, so for instance, let's say we want to download the median income variable that we just saw. We can have the get census function is the main function that we're going to use to download the data directly from the census. It's going to, again, the name, the vintage, the variable names, the region is going to be our main parameters. So the name of the data set is going to be ACS, ACS5. The year we're looking at, vintage, is 2016. Now, you've probably seen this maybe in the previous class, but we don't want to just look at one variable. We want to look at several variables. So the way we can pass this command to the vars function is to use the concatenate function C parenthesis. And basically, we're going to combine 3 variables together. So R will know to download these 3 variables, the name of the real name of the variable, and then, or I mean, sorry, this is going to be the name of the geography. And then the 2 variables we're interested in related to median income. The region is going to be county, but we're also going to look specifically at the state of Arizona. And I mentioned to you the FIPS code, the first 2 digits refer to the state. So Arizona's FIP code is 04. So this is going to basically subset all of the county level data to only the counties within Arizona. And if we look at the head of our data set called AZ income, we'll see we have a list of the different counties, and we have the variables, the 2 variables that we called in, okay? And the name variable is the county and the state, okay? State here is the first 2 digits of FIPS, 04. Again, the FIPS 3-digit at the county level, again, referred to the FIPS code that we saw in the last video, okay? So for data exploration, we can manipulate some of the data. We can rename the median income, this ugly looking variable, and rename it as the median household income underscore estimate. And the second variable that we called in refers to the margin of error. Again, because we're using sampling data, so they don't look at all of the household sample, they just take a subset of the US population. So there'll be a margin of error with respect to this estimate. So we can use this margin of error information to see how certain we are that this estimate is accurate for every county. And what we're going to do is look at the standard error of the margin of error, calculate the margin of error, standard error, and compute the coefficient of variation. This will give us essentially the amount of uncertainty surrounding our main estimate here for household median income. And we can use ggplot, which is the main plotting function in R. My understanding is you guys worked with only the R in-house plot feature. If we look at ggplot, this will allow us a little bit more intuitive way to plot some pretty nice looking plots. So you don't have to worry about the code now. I just want to give you an example of what we can do. What we're wanting to do is create a bar plot where we're going to have our main dots and the dot plot for a dot plot be the median household income estimate. And we're going to want to put error bars around each dot that show how much uncertainty there is with respect to each estimate. Okay, so we in ggplot there's geom point, and geom arrow bar is what we're going to be using to create this error bar or this bar plot. And we'll come back to this later. I just want to show you the outcome right now. If we're looking at Maricopa County, we see a household median income above 50,000 and a very small error bars. This means that the precision of this estimate is very high, likely because it's a very high population density area, so there's a lot of surveys carried out here. So our confidence that this estimate is accurate is very high. Whereas if you look at Greenlee County in Arizona, the error bars are extremely large. So there's a high level of uncertainty surrounding this estimate of around 50,000. median household income. And this is likely, again, that the number of samples or the number of people interviewed or surveyed in this county are probably a lot lower. So our certainty that this estimate of just the sampled households actually reflecting the population estimate, that is the true value, we're a little bit much less certain about this estimate than for Maricopa. And we can see across all the different counties, the uncertainty levels vary quite extensively from very high confidence to very low confidence between Maricopa and Greenlee counties, for instance. So again, this is just a basic exercise looking with ggplot for our first time and interpreting some important information surrounding how likely or how much confidence do we have in the estimates being recovered by the Census Bureau. Okay, so let's move on to downloading the spatial data. So the spatial information contained in the census. And to do this, we're going to use the library Tigris. Again, you have to download the Tigris package and load in the library if you want to use this. If we want to set the counties for the spatial information we want only to Arizona, this is how we would do it. And for CB set to true, we have CB equals true is basically just the resolution, the high scale resolution 1 to 500K. So this is a basic way that we would be able to view the spatial data. If we view it as a spreadsheet, we'll see stuff that looks pretty similar to what we've seen before, the FIP code for state, FIP code for county. We have some more some geoid information. The geoid is just putting the state FP and the county FP columns together. We have the name of the county, and we have the information on the land and water. The big thing we're going to see is a geometry variable, and we'll see this even in the tutorial in the next video. Basically, the geometry variable is capturing the latitude and longitude of the polygon. So here we're looking at counties. This geometry is including all of the latitude and longitudinal coordinates to create that boundary for each county, okay? So it's nothing that we have to analyze. This is just information that is downloaded from the census, and this is what helps to draw the actual physical boundaries in our mapping, okay? So I mentioned what are the variables. You can read it here. Again, using ggplot, this is our main plotting function. We have the data that we want to apply is AZ. We can use the geom SF. The SF is the type of spatial data that we're looking at. And if we run this code, it'll give us just a blank canvas map of Arizona and the different counties. Okay. Just some notes on code, because I know you haven't looked at ggplot before. To kind of explain what's going on here. Everything down here is essentially just aesthetics to make the map a little bit more visually appealing. If you wanted to rerun this code and get rid of just run this part, you'll have the exact same map, just a little bit less aesthetically pleasing. So this is just a bunch of extra codes we can tie in to make the map a little bit better. Okay, so the next step using this Tigris and the Census API data is to join the map data and the median income data together. Okay, so remember, we've downloaded two different data sets. We've downloaded the demographic data in the census for median household income, and we just downloaded the map data for Arizona at the county level. So now we need to merge these two data sets together. And to do that, we can just first make sure what our variable names are. So if we look at the first row of our Arizona, our demographic income data for Arizona, we'll see state, county, name, and our two variables for median income and the margin of error. If we look at our AZ data set, this is the spatial data set we just downloaded, and we look at the second variable, we'll see something that looks like this. These 3-digit numbers are, again, referring to the county within Arizona. And the name of this second column is called County FP. Okay, remember from our previous slide. county FP. Okay, so this is the second column in that data set. So basically what we want to do is we want to merge the two data sets based on the count. This should be county FP in our spatial data and our county variable name and our demographic data. So to do this, we use the left join feature. We want to join the Arizona spatial data set with the Arizona demographic income data. And the county FP comes from our AZ data set, and the county variable name comes from our AZ income data set. And we're basically going to have our match all the information based on these two variable names. So this is going to create a new data set, AZ forever. And if we look at AZ forever, we can check to see if the merge worked. We can see we have our geometry, spatial information, and we also have our demographic variable information on median household income and the margin of error. And if we look at the first row, again, it would just confirm we have our geometry, our latitude and longitude to actually map the geographical boundaries for each county, and we have our demographic data for household income. Okay, so if we want to plot this information, again, we're going to use the ggplot plotter function. We have our data name, AZ forever. We're using the geom SF. This is again, the inherent code to tell ggplot that we're looking at spatial data. And AES is the aesthetic value for how we want to fill each of the geographical boundaries. So we put in the fill command, and we're going to fill it by the median household income, and we're going to have the outside boundary color as white. Okay. Again, we have the theme void and all this stuff for aesthetics. Basically, all within here, we're telling the R to plot the colors, the gradients of colors from low median income to high median income based on oranges, the color orange. And we're going to name the legend as median income, which goes here, median income. And we're going to give the plot a title, 2016 median income in Arizona counties right here. And we're going to add the caption where our source of data source is coming from, U.S. Census ACS 5 for 2016. And that source information comes down here. Okay. So again, we won't have to use this for our lab, but this is basic idea of how we can create maps in R. Okay, so in the next video, it's going to be the most important video, and we're going to be using the newest kind of package called Tigris Census that allows us to download or load in into R both the demographic data and the spatial data from Census all at one time. So we don't have to join the data, we don't have to merge the data together. It's extremely easy and user-friendly. So we'll come back in the next video. We'll come back in the next video and do a tutorial and walk through, which will be directly related to your lab too. Okay, so make sure to tune in for the second tutorial, the fourth video, the next video. Okay.